Welcome to this video on circles and angles, a masterclass designed for your Kerala SCERT Class 10 SSLC exam preparation. We will cover key concept proofs, derivations, and provide quick revision summaries to help you master this chapter. Let's begin by understanding arcs and central angles. The central angle of an arc determines the fraction of the circle it covers. For instance, a 120-degree angle covers 1/3 of a circle, while a 60-degree angle covers 1/3 of the circumference. Next is the half-angle theorem. This states that, if the ends of an arc are joined to a point on the circle, the resulting angle is exactly half the central angle of that arc. This is proven using the properties of isosceles triangles and outer angles. Building on that, we have the semicircle right-angle theorem. Because a semicircle's central angle is a straight line at 180 degrees, any angle subtended by a semicircle at the circle's edge is always 90 degrees, forming a right angle. This theorem is highly practical. For example, you can use it to construct a perpendicular line at the endpoint of a segment by drawing a circle where that segment serves as a diameter. It also explains how triangles behave within circles. Applying these theorems to clock-face problems or triangle construction becomes easier when you remember the central angle rule. To construct specific angles, like 50, 60, or 70 degrees, simply double them to calculate the required central arcs. Now consider angles in the same segment. A chord splits a circle into segments, and the fundamental rule of geometry is that all angles formed by the same arc in the same segment are equal. The alternate segment theorem takes this further. It states that the sum of angles made by points on one arc and its alternate arc is always 180 degrees, meaning these angles are supplementary. When solving problems for your exams, keep these two patterns in mind: the 80/100ths degree relationship where angles sum to 180, and the algebraic split where you can solve for angles given a specific ratio like x and 2x. Moving to cyclic quadrilaterals, a cyclic quadrilateral is one where all four vertices lie on a circle. The opposite angles theorem states that the opposite angles of a cyclic quadrilateral always sum to 180 degrees. The position of the fourth vertex also matters. If it's outside the circle, the sum is less than 180 degrees. If inside, it's greater. Additionally, the exterior angle of a cyclic quadrilateral equals the opposite interior angle. Not all shapes are cyclic. Rectangles and isosceles trapeziums are, but general parallelograms and non-isosceles trapeziums are not. Also, note the rhombus diameter theorem, where circles on the sides of a rhombus pass through a common point. Advanced problems may involve intersecting circles or angle bisectors. By identifying these properties, such as proving segments of intersecting circles create new cyclic quadrilaterals, you can solve even the most complex exam questions. To wrap up, remember these key takeaways: half-angle properties, the 90-degree semicircle rule, the 180-degree sum for cyclic quadrilaterals, and the supplementary nature of angles and alternate segments. Use this summary for your final review.